everyone, welcome to another video, and today we are going to discuss about the formation of a rainbow. So without wasting any more time, let's get started. So in our previous video we have seen how a prism disperses light. So we know how light is scattered or light is dispersed into 7 different colors. It is starting from violet up to red based on their wavelength. So today we will see an application of this, and by application I mean the formation of rainbow. Now, when does a rainbow form? That is the first question. Is when a rainbow forms. Rainbow is formed always after some rainfall, or if you see sunlight through a fountain or through a waterfall. At that point of time you can see rainbow. That means we need water for the formation of rainbow. It may be rain or it may be a water fountain or a waterfall. We need water in order to see the formation of rainbow. Now the question is, why water? Now see, in our atmosphere we can't have prisms hanging around in the sky where it will reflect light or diffract light or disperse light to 7 colors. So which thing actually performs the function of a prism? It is the droplet of water. So after rainfall, whenever the droplets of water are suspended in the atmosphere, they will act as prisms in the atmosphere and they will disperse light to 7 different colors. Now it is not that easy, because there are two things that actually take place. One is the refraction that happens in a prism. There is another phenomenon called the total internal reflection. So let us first understand what is total internal reflection before moving on to how the droplet works, because this is a new concept. So let's understand that. Suppose you take a glass slab, just like the glass slab we used in our previous chapter, we did in our practicals. Suppose we take one glass slab. Now, if light comes and falls on this surface, what is the fate of this light? What will happen to this light? It will reflect, right? It will reflect. It will move towards the normal. Okay. Now, if I bend the light even more, it will be like this. Obviously, because this is the original angle. If you try to bend more towards but the bending will proportional to the amount to the angle right here, right? Because sine I by sine R is always constant. That means the angle of reflection will depend on the angle of incidence. Okay, so if the angle of incidence is more, the angle of reflection will also be more. So the more I keep on bending the light, the more the reflection becomes like this. The more I keep on bending, and at some point of time, let me redraw it again. At some point of time you will observe that as I keep on bending light, as I keep on bending the light, at one point of time there is no reflection, because this reflected ray is getting up, and at one point of time it will be exactly in the line of the glass slab. That means refraction has stopped. There is no refraction. The incident light is coming, it is falling, and it is just sliding over the surface of the glass. That means refraction has stopped. This angle, now we draw the normal. This is not normal. The angle of the incident ray at which the angle of refraction is exactly 90 degree, because reflection angle is this one, right? So the angle of incidence at which the angle of refraction is 90 degree is called the critical angle. Okay, so this is one new term. Critical angle means it is the incident ray forming an angle with the normal at which no reflection takes place. It goes exactly on the surface of the glass slab. Not like glass, you can take any other substance, but it does not have any reflection. So it is a very new thing. So now how do we use this? What is the use of this? If we go far away from this critical angle, if we go further ahead, if we bring the light coming for much greater angle, what will happen? This will go even further up. Now here is the thing, here is the new thing. At this point of time what we are saying is there is no refraction, rather there is reflection. So all the light that is coming here, rather than refracting, it is actually, it seems like the light has come in, it is bounced off the surface. Just like if you throw a stone on the pond, you will see that the stone skips on the surface, it bounces on the surface of water. Exactly in the same way, it seems like the light has come and is bounced off the surface. But that is only possible at a particular angle. Just like I give you the example, if you take the stone and throw it directly from the top, it will just drown in the water. But if you throw it at a very less angle, forming a very less angle with the surface of the water, or a very big angle with the normal, means very from a slanted angle if you throw the pebble, then the pebble will bounce. Similarly, if you throw, but if the light comes from a very slanted angle, then it will not refract anymore. It will start to go up. So more of this light coming in this, the more we bend it, the more the light will keep on reflecting. This phenomenon where all the light falling into this point, falling into the point of incidence, does not refract but rather reflect, is called the total internal reflection. Okay, now we move on to how rainbow is formed. So I hope the idea of critical angle and total internal reflection is clear. Now let us move on to see how a rainbow is formed. Let us take one droplet of water, just as an example. So now, as I say, you should always remember that rainbow is formed in the opposite direction of the sun. So why? Here we have the sunlight coming in. It means the sun is somewhere here. Sunlight comes in. Because of refraction, there will be dispersion of light, there will be refraction of light. Because of refraction, as we know, there will be dispersion based on the wavelength of the light. So this will be your violet light, this will be your red light, just like the prism. Here is where internal reflection takes place, total internal reflection. So rather than reflecting out in this direction, it will reflect in this direction because the angle formed is much more than the critical angle. So what happens here, this goes like this and this will go like this. And from here, we will have another reflection. So this light now is dispersed into its 7 different colors. This is the red, violet, this is the red, violet. And here is the observer who is trying to observe the rainbow. And for him, it will seem like the rainbow is coming from this direction. The sun is in this direction. But for the observer, the rainbow will seem like to be in that direction. It is exactly opposite to the direction of the rainbow. And that's how a rainbow is formed. Okay, so if there had been no total internal reflection, in that case also rainbow would have been formed, but it would have been formed in this direction. The rainbow, the light would have scattered in this direction, it would have refracted back in this direction. Because of total internal reflection, we say the rainbow is formed at the opposite direction of the sun. So sun will be here, and for the observer to see that the rainbow has formed somewhere here, because of this droplet of water. Now, because of the huge amount of droplets of water in the sky, what we see is a big rainbow forming. I think you will be amazed when you see. I think some of you may have observed, but if you have not observed, I would like you to go near any fountain. So in any park, well, now you can't go because of the quarantine. But if you have observed earlier that near any waterfall, if you look through the drops of water coming out of the waterfall, not in the main waterfall, but just away from the waterfall. If this is a waterfall, suppose, if this is the waterfall, here you will see many droplets of water, huge amount of droplets of water in this position. Here, if you look from a distance, you will see that rainbow has formed here. So this is because of the same effect. So wherever there is droplet of water, you can see rainbow. But we don't really see rainbow when there are no droplets, rather there are the huge body of water. Like you will not be able to see rainbow in this region where there is complete body of water falling. Rather we need droplets, because in those droplets this phenomenon will take place. First it will refract, then there will be total internal reflection, and then we will have another refraction because of the change in medium, and hence the rainbow is formed. I hope this concept is clear to you, and there is a new concept, total internal reflection, there is a critical angle. I hope you understood these two, and this one is an application of the refraction by a prism. So dispersion of light by prism to form a rainbow. I hope you understood. Thank you everyone for watching, and in the next video we will move on to the twinkling of the stars, and later on we will go on to see why the color of sky is blue during the day and red during the night. Thank you everyone for watching, and until next time, cheers.